Hello and welcome. In the previous lesson, we talked about how servo motors work. We will frequently use servo motors in our projects. When selecting a servo motor, there are several important criteria we need to consider. One of the most critical factors is the size of the servo motor, as this can significantly impact how well it integrates with our projects. Additionally, we must also pay attention to the gear structure, which we discussed in the previous illustration, as it directly affects the motor's performance and durability. Furthermore, it's essential to evaluate the electronic working principle, operating voltage, and motor type to ensure compatibility with the specific requirements of our project. Careful consideration of these factors is crucial for successfully implementing our projects without encountering issues. For example, one of the projects we can undertake using a servo motor is building a model airplane. During the construction of a model airplane, servo motors can be used to control the flaps on the wings, the tail section stabilizers, and the rudder, which is responsible for steering the plane. This precise control provided by servo motors allows for smooth and accurate maneuverability, making them indispensable in such applications. Here, we're looking at the details of the project's design. Servo motors play a key role in controlling both the rear stabilizers and the rudder, showing their versatility in motion control applications. This makes them an essential component for many Arduino-based projects that involve movement. The size of the servo motor is one of the key factors to consider when selecting it for this plane. For example, in model airplane construction, using a large servo motor wouldn't make sense for a standard-sized airplane. However, for larger models, a bigger servo motor could be necessary. In most cases, smaller servo motors with higher torque are more suitable for achieving precise control and efficient operation in compact designs. When it comes to servo motors, they come in various sizes, each suited for specific applications. These sizes are commonly categorized as nano, micro, mini, standard, and jumbo. Their weights vary depending on their size. For example, nano-sized servo motors weigh between 2 to 5 grams, making them ideal for small and lightweight projects. The micro-sized servo motors, which we frequently use in our projects, typically weigh between 6 to 15 grams. On the other hand, jumbo servo motors, which are the largest, can weigh between 100 and 250. Another important factor to consider is the gear structure of the servo motor. Gears are typically made from materials such as plastic, carbon, or metal. Among metal gears, various alloys are used, including aluminum and similar components, to create durable and efficient metal gears. Additionally, there are servo motors with gears made from stronger materials like steel and titanium. If your project requires frequent or intensive use of the servo motor, it's better to choose metal gears instead of plastic ones to prevent wear and tear. Among metal options, titanium gears are the most durable, offering the highest strength and resistance. Moving on to the electronic aspect of servo motors, there are two main types, analog and digital. Analog servo motors are known for their lower energy consumption, making them more energy efficient. However, digital servo motors, despite consuming more power, provide greater precision and faster response times. This makes digital servo motors a better choice for projects that require precise and quick movements, such as model airplanes, drones, or other projects where accurate angles and immediate reactions are essential. That said, the higher energy consumption of digital servo motors can be a disadvantage, especially in battery-powered applications. Servo motors also differ in their operating angles. While most standard servo motors are designed to operate between 0 and 180 degrees, there are models capable of working at 120, 180, and even 360 degrees. Choosing the right range depends on the specific movement requirements of your project. Another crucial factor is voltage. Servo motors are available in different voltage ranges, such as 4.8 to 6.8 volts, 4.8 to 8.4 volts, or even higher ranges like 11.1 to 14.8 volts. While there are servo motors that operate at much higher voltages, we typically avoid using those in Arduino projects. The servo motors we use in most Arduino applications run on DC, while AC servo motors are primarily used in industrial applications and factories. Lastly, the type of motor inside the servo motor is another key consideration. There are coreless DC servo motors, which are lightweight, provide quick response times, and offer smooth movements. There are also brushless servo motors available, known for their high power, efficiency, and durability. These brushless models are ideal for applications that require both high performance and longevity. Let's now examine the differences between digital and analog servo motors. Digital servo motors are up to 10 times faster and have 3 times more torque compared to their analog counterparts of the same specifications. This makes them an excellent choice if speed and torque are critical for your project. One key advantage of digital servo motors is their precision. They operate at very high frequencies, allowing for finer and more accurate movements. Moreover, many digital servos have the ability to be programmed, which adds flexibility in advanced projects. However, the main downside of digital servo motors is their higher energy consumption. Analog servo motors, on the other hand, are much more energy efficient and often sufficient for many standard projects. But for professional and advanced level applications, transitioning to digital servo motors may become necessary. It's worth noting that the energy demands of digital servo motors cannot typically be met by standard dry cell batteries. Instead, lithium polymer batteries are required to provide the necessary power. To better understand the differences, let's compare a digital servo motor and an analog servo motor from the high-tech brand. The digital servo model, the HS1100WP, operates at a voltage range of 11.1 to 14.8 volts, whereas the analog model, the HS750HB, operates at a lower voltage range of 4.8 to 6 volts. This means the digital servo motor consumes nearly 3 times as much energy as the analog model. When we look at speed, it is measured by the time it takes the servo motor to move through a 60-degree angle. The digital servo motor has a speed range of 0.19 to 0.26 seconds for a 60-degree rotation, while the analog servo motor is slower, with a range of 0.23 to 0.28 seconds. As mentioned earlier, digital servo motors are significantly faster and more powerful than analog ones of similar specifications. However, this comparison is valid only when both motors share the same physical characteristics. Otherwise, the differences may vary. In terms of torque, the digital model has an impressive capacity with a maximum torque of 84 to 110 kilograms per centimeter. This means that even if you attach a 1 centimeter long arm to the motor and place a load of 100 kilograms on it, the motor can lift it with ease. By contrast, the analog model has a maximum torque of 11 to 13.2 kilograms per centimeter. The power consumption differences are also noteworthy. When idle and under no load, the digital servo motor draws 130 milliamps of current, while the analog motor draws only 8 milliamps. Under load, the digital servo's current draw can reach up to 1300 milliamps compared to 250 milliamps for the analog motor. This highlights the superior energy efficiency of analog servo motors, which makes them ideal for projects with limited power resources. Another consideration is whether the servo motor is waterproof. Both digital and analog servo motors are available in waterproof versions, so if you're working on an underwater project or building a submersible vehicle, you can choose a model designed for such conditions. Waterproofing is not a feature exclusive to either digital or analog motors. Both types have models that can meet this requirement. In conclusion, both digital and analog servo motors have their strengths and applications. While analog servos excel in energy efficiency and are suitable for most standard projects, digital servos shine in advanced applications where speed, precision, and torque are essential.